Okay, so our final lesson is on geometric series in this set of lessons. So you've already seen a series before when we talked about arithmetic. And remember, a series means a sum. So now we're adding up all the terms. We have two formulas that you'll want to add to your notes to use. So the sum of n terms is the first term, right? That's T1, times the common ratio. This is the number of terms, minus 1 over divided by the common ratio minus 1. So this is when I have term 1 and the number of terms. And of course the common ratio. Whereas down here, I don't know the number of terms, but I know the final term. So I have term 1, sorry, that's here. The final term, term n, that's this, and the common ratio. So the difference here is I don't know the number of terms. And in this one, I don't know term n. So I've got two choices. So think about when do we use which one. So down here, I have a geometric series, 1 plus 2 plus 4 plus 8 plus 16, and so on. And so down here, I can see that term 1 is 1. The common ratio is 2. Remember, I get that by taking any term and dividing by the 1 in front of it, for example, and that gives me the common ratio of 2. I know that n is 12, but I don't know term 12. So that means that I can't really use this formula without finding term 12 first. So in that case, I'm going to pick this formula, and it's easier for me to do. So the sum of 12 terms, the sum of 12 will be term 1 times the common ratio to the power n, take away 1, all divided by the common ratio minus 1. So if I put this into my calculator, I'm probably going to do this first, 2 to the power 12, then I'm going to subtract 1, and then really in this one I'm timesing it by 1 and dividing by 1, so it's just that number, 2 to the power 12, which is 4,096, and I take away 1, 4,095 is the sum of 12 terms. So down here I have some more examples for us to work through. This one, term 1, is 1/2. And it looks like the common ratio is also 1/2. You can see that I took 1/2 and I timesed it by a half to get a quarter, and then I times that by a half to get an eighth, and so on as I go along here. So Tn would be the general term. This is a throwback to last lesson. So that would be the first term times the common ratio, which happened to be the same value, to the power n minus 1. What is the sum of 6 terms? The sum of 6 would be term 1 times the common ratio, so I'm going to put in brackets like that, to the power n, take away 1, divided by r minus 1. I'm using, again, this formula here. So that's going to give me kind of an ugly decimal in my calculator. It is 0.984375. Okay, so 12 terms is going to be even uglier, so let's just skip that and look at what else we have. So here's a slightly different one. Can you see what r is and what Tn is for this problem here? Maybe take a moment and try and do that. Try and find the sum of 6 and see what you get. Okay, so over here, term 1 is 1/2. The common ratio you can see this time is negative 1/2. So Tn is going to be term 1 times the common ratio to the power n minus 1. That's finding our sequence. That's the general term for the sequence. The sum of 6, again, I'm going to use that, that first formula. So sum of 6 would be term 1 times r to the power 6 minus 1 over r minus 1. So I'm going to put in this part first, negative 1/2 to the power 6 in my calculator. I'm going to take away 1 and get that answer, and then I'm going to times it by 0.5, and that's this here, and then I'm going to divide it by this. So divided by bracket negative 0.5 minus 1 is 0.3385, blah, blah, blah. So these ones aren't really the nicest to work with there. Let's move on. So here I've got the same one as the first, and we already found the sum of 12, but we can find Tn and so on. So Tn would be term 1 times r to the n minus 1, the sum of 6. So there I'm going to have 1 times, in brackets here, 2 to the power 6 minus 1 over 2 minus 1. So I'm going to put 2 to the power 6, which is 64, minus 1 is 63, times 1 over 1 is 63. We already did this one, all right? And down here now, I have a slightly different set of problems for you to try. So in the first one, now we're looking at our other formula. So let's grab that formula from up here. And this time I'm referring to this one. So make sure you have that handy because we're going to be using that guy down here. So let's just write it out here. The sum of n terms is r times Tn minus T1 over r minus 1. And the reason why I'm using that one, you can see I don't know how many terms are represented by these dots, but I know that this is the last term, and I know this is the first term. And you should be able to see the common ratio is 1/2 in this case. So my calculation for the sum of n terms, whatever n is, I don't know, is 1/2 times term 1 minus, or sorry, times term n. I made a mistake there. Let's get rid of that. Times 1 over 64 minus term 1, which is 8, divided by r minus 1. So my calculator, I'm going to go 1 over 2 times 1 over 64 and take away 8. And then I'm going to divide it by 1/2 minus 1. And I get 15.98. There are some other decimals there, 984375. So this leads into another topic, which we call an infinite sum, where we keep adding more and more and more and more pieces, and then at infinity, we can find the sum. And I'm guessing here it's probably going to be 16. We're just going to get ever closer to 16. So why don't you try this last question here, where we're practicing a very similar thing with the use of this formula. Okay, so term 1 is -2. R is also -2. The common ratio, Tn, -8,192. And now we have enough information to find the sum of all these terms. So R times Tn minus term 1 all over r minus 1. So I'm going to put in 8,192 negative times negative 2 gives me 16,384. It's positive, and I'm going to add 2 to that. Remember, that's what this really means. And I'm going to divide that by my common difference, negative 2, subtract 1, and that's going to give me negative 5,462. So I hope you found that as well.